Just a few days after the announcement of the Tri-Eye Atlas comet, set for July 1st, 2025, the news exploded on social media. Unprocessed telescopic images of this new interstellar object were allegedly leaked, but the National Security Agency refused to confirm it. Official sources claim there was no data for publication. Yet as the story spread, the space community split between skeptics and true believers. Trust in our efforts to protect the planet is questioned, fueling rumors and raising suspicion about the NSA's silence. Responses and risks begin right here. A few hours after the announcement, the story starts to take on a life of its own, beginning with a few posts on social media. Each of them becomes increasingly captivating. The first mention of the leak appears on the Flying Science forums at 2118 UTC, just as the first official images of Atlas begin circulating among astronomers. A simple yet explosive statement. A technical specialist with an anonymous name, working at a major telescope, allegedly leaked raw, unprocessed images of Tri-Eye Atlas, while the NSA refuses to comment. There is neither a source nor references, only a screenshot of text that quickly spread through messengers. By midnight, the data leak about Atlas becomes a trend in 3 countries. In one TikTok video, someone scrolls through a blurred image that no one knew about, gaining 40,000 views in the first hour. Themes of astronomy and UFOs gather hundreds of comments, most demanding proof or directly refuting rumors. Neither a technical specialist, nor a supply chain, nor metadata exists, but the more a rumor is doubted, the faster it spreads. One of the YouTube channels with 200,000 subscribers publishes a video titled, "NASA Caught Hiding Images of an Interstellar Comet." The video flashes official images obtained from the Gemini and Hubble telescopes, all with bright color filters and dramatic music. In the comments, users debate whether these are real or unedited files or just reworked press releases. By morning, the video has garnered 50,000 views. Meanwhile, dozens of Facebook pages dedicated to space share the same claim, each adding a new twist. Some argue that unnatural structures are visible in the photos. Others insist that the technician is hiding. None of these statements are backed by evidence. By July 2nd, the story transcends language barriers and begins to appear in reports in Spanish, Russian, and Japanese. Moderators of the platform start labeling the most viral statements as unverified or misleading. Nevertheless, the rumor mill continues to operate, and the lack of an official denial only adds fuel to the fire. For some, this is enough. For others, it is yet another reason to dig deeper. In less than a day, what started as an anonymous post became an international sensation, attracting skeptics, believers, and everyone in between. By the morning of July 2nd, the online community had split into 2 camps. On one side, the believers filled discussions with theories and blurry screenshots, convinced that the silence of the National Security Service was a cover-up. On the other side, skeptics meticulously analyzed every pixel and metadata, demanding real evidence. By noon, the hashtag had reached 120,000 mentions, with peak activity occurring on X and TikTok platforms. Comments ranged from technical jargon to bold speculations. Some users insisted that the images were evidence of extraterrestrial technologies, while others pointed to colored filters and repurposed press materials. Several well-known science popularizers called for caution. Phil Platt, a famous astronomer, tweeted that if something important exists, someone must provide the original files. Otherwise, it's just noise. His post gathered 4,000 likes in 2 hours but quickly got lost in the flow of responses proposing new theories. The moderators of the astronomical community closed the main discussion thread after 1,200 comments, citing a flood of unverified information. Some users began tracking the spread of the story in real time, identifying accounts that picked up the plot. Bots and memes seized the hashtag, promoting it to trends in Brazil and Japan. The TikTok creators edited video reactions, and one of the clips featuring an emotional reading of the original post garnered 80,000 views before noon. The lack of a clear answer from the National Security Service itself became fuel for disputes. For every call for patience and expert evaluation, there was another claiming that silence was evidence of information concealment. Debates hit the front pages, and morning talk shows began airing segments about the controversial comet. Reporters reached out to the National Security Service, but received only vague responses. All official data will be published after verification. In this chaos, the initial statement was overshadowed by new rumors. Some reports claimed to have insider sources, while others pointed to alleged informants who never appeared. By the end of the day, the only thing everyone could agree on was that no one had seen the original files. But the debate, believers against skeptics, silence against transparency, became the story of July 1st 2025. The Atlas telescope in Chile scans the sky, searching for moving points that don't fit the usual pattern. That night, the device detects something strange, an object racing at over 130,000 miles per hour. This is not just another comet. The Center for Small Planets receives a warning within minutes. By the end of the day, astronomers in Europe are tracking its trajectory, checking data, and conducting orbital modeling. The data points become clear. This object is not related to our solar system. His hyperbolic trajectory, measured with high eccentricity, indicates that he will never return. Within a day, the Small Planet Center will publish a circular confirming the team's assumptions. This is an interstellar visitor. Only 2 such objects were discovered: UML in 2017 and Boris in 2019. Now this list is joined by 3 Yatlas, placing it third among registered interstellar objects. The next step is to assess its size. Previously conducted photometers suggest that the core of the object is 15 miles wide, significantly larger than its predecessors. The speed is also record-breaking. Calculations show it exceeds 210,000 kilometers per hour, surpassing any known comet or asteroid on its trajectory out of the solar system. Astronomers are rushing to model its future trajectory. Perigee, the closest moment to the Sun, is scheduled for the end of October. This leaves only a few months for ground and space telescopes to gather data before the object disappears into the abyss again. The detection system from LOSA, designed for planetary defense, is now the front line of interstellar research. Automated software checks images for astrometric accuracy. Each new observation refines the orbit, reducing errors. The public bulletin from the Center for Small Planets sparks a flurry of additional requests from observatories around the world. The urgency of the situation is evident. With each passing hour, the window for study narrows. This is a rare discovery. Its uniqueness compels the scientific community to work at an accelerated pace. Teams with a giant telescope and Hubble are planning emergency observations. The brightness of the object, its trajectory, and potential age, possibly billions of years older than our solar system, create additional pressure. For planetologists, this is a chance to study unaltered material from another star. For the Atlas team, this is a confirmation of years of efforts to create a system capable of capturing what eludes the attention of almost everyone else. By the end of July the 2nd, the foundations will be laid. 3 Yatlas and Atlas are great, fast, and not from here. Its official status as an interstellar object is confirmed. The race continues to capture every possible detail before the comet disappears forever on July 15th, 2025. A sequence is being filmed through the Jamie North telescope that will become a benchmark for astronomers worldwide. In one night, the team takes 16 photographs, each passing through different parts of the visible spectrum. As a result, a frame-by-frame shot is created, showing 3 eyes of Atlas drifting across a field of stars, their coma glowing in changing shades of blue, green, and red. Each color is the result of careful layering of images and filter selection, a digital trick. In reality, the light of the comet is almost white, but these images reveal the subtle details of gases and dust erupting from its core. Processing begins immediately after uploading the raw data to the observatory's servers. Astronomers use calibration files to eliminate background noise, cosmic ray impacts, and artifacts occurring on sensors. Each frame is aligned with pixel-level precision and then combined into high-resolution composite images with minimal distortions. The final result is both a work of art and a scientific document recording an object that until recently remained unknown. At the end of July, the Gemini South telescope located in Chile joins the research. On August 27th, new images confirm the astronomers' observation goal. A barely noticeable but distinctly visible tail stretches from the nucleus. Solar radiation heats the comet's ice, causing gas and dust eruptions into space. Karen Misch, an experienced comet researcher from the University of Hawaii, describes this moment as a scientific milestone and a source of wonder, noting that while the comet swiftly returns to the depths of interstellar space, this image serves as both a scientific landmark and a source of admiration. Other observatories also provide their images. A huge telescope in the Atacama Desert took a composite image in July, using adaptive optics to overcome atmospheric turbulence. Images captured by the Hubble telescope and published at the end of July show the fine structure of the coma and tail at higher magnification. Each dataset is accompanied by metadata containing observation time, instrument settings, and calibration data. These are not just beautiful images, but dimensions that complement the evolving portrait of Comet Atlas. The variety of reliable data sources is impressive. Atlas, Gemini, VLT, Hubble, and soon a website. Each uses its own methods and perspectives. Some observatories use broadband filters to capture faint structures, while others analyze light by breaking it into spectra in search of traces of water, carbon dioxide, or exotic ice. Each image is processed according to established protocols, and the processed and edited data is archived for public access. Access to them is granted after verification, and for scientists, these images represent not just evidence of discovery, but a window into another history of the solar system and an example of how quickly the global research community can act. In just a few weeks, the world moved from rumors and assumptions to a mosaic of verified observations, each assessed by experts, each a small victory in the quest for knowledge about a cosmos that will never return. All data from the NASA-funded telescope undergo a strict process from observation to publication. The rules are outlined in SPD 41, NASA's policy on scientific information. For most missions, raw images and data are stored for a period of 6 to 12 months, giving leading researchers an advantage in analysis. However, for high-profile discoveries, such as interstellar comets, this period may be shortened. Sometimes urgent goals are published in an accelerated manner. But even in such cases, nothing becomes available to the public without electronic documentary confirmation. Archive managers in institutions like MAST and Gemini record each file from the moment it is received. Access logs record who and when uploaded materials, from which account. If a technician or researcher extracts raw images before the official release, this action is documented, saved, and can be verified. Each observatory has its own responsibilities for data storage. Conveyor maintenance specialists, data archivists, and lead researchers have different levels of access. Any violation or suspicious access triggers an internal check, and sometimes an official audit. Publishing images through certain channels requires bypassing automated checks and manual permissions. For a leak to occur, someone would need to circumvent not only password protection, but also the tracking system that logs every action. Therefore, the rumors about techniques that reveal raw files are not true. The silence of national security in response to messages about leaks is related not only to secrecy, but also to the process. Official comments appear only after reviewing logs, completing audits, and closing the tracking chain. Tracing the source of the alleged image leak requires an expert approach based on the publication platform. Investigators start with the usual suspects: X, Reddit, Telegram, and Discord. Each viral image is analyzed using reverse search tools like TinEye and Google Images for any signs of unique uploads or hidden metadata. Each result points to official sources: Atlas, Gemini, Hubble, or Vidi. Raw files from technical specialists are not made publicly available. The so-called leaks are merely copies of published materials with altered colors, sometimes cropped or blurred to appear new. Archive managers at MAST and Gemini check their logs for unusual uploads. Each file request is logged in the user's account, has a timestamp, and is linked to the observatory's supply chain. Unexplained access cases are not recorded, and there are no missing datasets. When requests under the Freedom of Information Act are sent to National Security and the University of Hawaii, the responses are identical. All three data points, AI and Atlas, were published according to a standard schedule, with no records of authorized dissemination or contacts with witnesses. Reverse image searches yield only repurposed images for the press. Every viral post and YouTube video claiming to contain exclusive content traces back to public archives or official press kits. The absence of an audit trail indicates a real leak. In the end, all the evidence is clear. Despite a week of discussions about the digital Southerner, not a single technical specialist was found, nor any supply chain violations, nor any unprocessed images available outside the public archive. Public interest in the 3 ICE and the Atlas has already surpassed official data, but the real consequences unfold in quieter corners: research laboratories, archival data, and political offices. When rumors begin to grow, the gap between speculation and evidence becomes something more than just discussion on social media. For planetary defense groups, even a one-day delay in image verification can mean a missed opportunity to refine the trajectory or composition of an object. The stakes are high, and precision is critically important when tracking something moving at speeds of 130,000 miles per hour, or 29,000 kilometers per hour. For those demanding answers, the Freedom of Information Act offers an official way. Anyone can request internal emails, audit logs, or reports from the National Intelligence Agency related to the three ice. There is even a template circulating on astronomy forums dedicated to requests to NASA under the Freedom of Information Act concerning supply chains, data processing logs, and any correspondence related to comet data. Historically urgent discoveries required rapid publication of data, especially concerning public safety or scientific value. However, this process is slow, and official statements rarely spread as quickly as online debates. Some astronomers believe that the best defense against confusion is transparency, prompt publication of data, clear storage records, and protocols for public verification. Others warn that excessive haste can lead to mistakes or misinterpretation, especially in the case of unprocessed images requiring careful calibration. Ultimately, the responsibility for separating facts from rumors often falls on NASA's Public Relations Department, whose subsequent statements can determine how this story will be perceived. The question remains open as to the right balance between speed, accuracy, and trust in the age of instant speculation. On July 1st, 2025, 3 objects were discovered during the ATLAS research, marking only the third confirmed interstellar object in observational history. The largest observatories, including Jamia, published verified images, following standard protocols and a strict supply chain.